Hey, what's up, YouTube? I'm just here doing a video on my converted Harbor Freight part washer. This part washer, I guess, is a newer version. I know they were coming in a color red, but this one I got it maybe about 3 weeks ago or whatever the case. And I did some mods to it, and I'm going to share what I did to it, and I'm going to tell you what makes this one stand apart from any of the other hot parts washer conversions that I've seen so far. I have, seen some ideas that I like from other videos, and I've incorporated those in this build, and I'll talk about those, and I'll link those that video um, underneath, and give credit where credit's due. I don't know the young man's name, but I can put the link to his video to his channel, and I will do that. But let's get into it. First off, you see the MP logo on the top and on the can, and that's just simply because that's my business. I do powder coating, and you can see the powder coating machine right there. I do sandblasting, laser engraving, vapor blasting, stuff like that. So, I take, old parts and I get them all, snazzied up, get them a fresh coat of powder and stuff like that, and I sell them. So I always would run into a problem. I would get parts from, pick and pulls, things of that nature, like calipers and things like that. And there's some over there, and I'll show you. And I will always run into the issue, I don't want to vapor blast them or whatever, or sandblast them, but they're so dirty, it just winds up messing up my blast cabinet. So I needed to clean these things, and some of the stuff has some strong grime and stuff on it. So I needed something that a little extra edge, and that's where the heat comes into play. So now let's get into it. The first mod I did was I removed the black shelf that goes on there. As you can see, those 4 bolt holes right there. Underneath, you'll see an oblong screw hole, and then it's like that on all 4 legs. So what I wind up doing was taking that out, because clearly the bucket that I have under there would not fit if that shelf was there. And I mounted a piece of wood on the bottom, as a platform to sit the bucket, and I put casters on there. I believe these casters can support somewhere between 50 to 80 pounds a piece. And this system is not very heavy. Water weighs 8 pounds per gallon, and this is a water-based degreaser that I have running in here. So 8 times 5 is 40. 40 pounds, give or take, plus the bucket, and then everything else is nowhere close to being, 200 plus pounds. It just isn't. So let's get back into this. Now, let's talk about the pump. This pump right here, it is a hot water pump, and this is one of those situations, ideas that I got from the video that I linked below. It's good. It's not a self-priming pump, and that's the only downside I can see to it, but it works great, and it's small and compact. It is very, very quiet. So I have that there, and we're gonna get into exactly what all this stuff is gonna do and what it's for. And here's my sediment filter. This is also another piece that the young gentleman used in his build, and it works great. But if I should say, if I was to have my choice with doing this, which redoing this, I probably would look for something a little more, I guess, matching my color scheme. It works great, but and I would want something maybe that has some a metal housing to it instead of plastic. So now, besides the casters that are on there, there's 4 casters, 1 on each corner. Make sure people know it's hot. So basically, on the inside, what I have going on here, I have a J37 intake manifold that is dirty. I'm gonna, vapor blast it and everything, but I got to get it clean first as much as I can. I have the Lyle parts brush, and this one has the liquid that flows through it, okay? And I also have a flexible, hose. I think it's called Lock Link or Link Lock or whatever it's called. But I can add more of these if I wanted to get more on this side to make the reaching easier. But for right now, I'm gonna leave it that way. And this is a priming ball, and I'm gonna tell you in a minute why I have that there. Okay. So now I decided to go with the 5-gallon bucket with the locking lid, And the reason for that is because there is an in-tank heater inside of here, and it's not your typical heater like a fish tank heater. This thing gets hot fast. It can heat this bucket up, you know, maybe 10 minutes or whatever the case, and this thing is about 120 degrees. And that's perfect because I'm running 130. Okay, and I did that because I didn't want to risk melting any plastic or anything like that. Now on the top, I retrofitted a shower drain. There's a shower drain there, okay? And you can see this degreaser is doing some work on that grease. And under here, shower drain is PVC. I did try to go with something that was metal, but I couldn't find anything metal to fit the exact way to make all this work. So I did go with that. And it is schedule 80, so at least the drain part is. So it should work just fine. And I also have a hot water flex hose for a water heater. Now, it comes in a pack of 2. It comes with the red one, it comes with the blue one. It's 3/4 inch. I decided to go with the red for obvious reasons. So basically inside of this bushing, it is 2 inches to 3/4 inch. And I have a 3/4 inch NPT fitting here. And it goes into this water heater hose. Now, I did not have to use Teflon tape, but I did because this thing actually has a gasket, like a water hose has a gasket on the inside. So it's kind of like a compression, but not quite. It actually fits NPT threads. And it goes down into the bucket. That's the return, the drain from the top. And this is a closed loop system. Now, the reason why I have this black elbow fitting here is just to, if it gets too hot and things start to expand, it can just relieve any pressure. And that's all that is there for. I have a 90-degree elbow inside of a stainless bulkhead fitting. I have a combination of brass and bulkhead fitting. Brass there, stainless there. It doesn't really matter. And so one side of that 90-degree elbow is 3/8 NPT thread, and the other end of it is 3/8 compression. So with that, it gives me the ability to use this braided line, which is, I believe it's like a sink line, and I got those all throughout, and I think it just makes it look a lot more better. Okay, so as you see right there, that is actually copper. I sweated some copper together, and I sandblasted it to make it easily cleanable, and I painted it red and mounted it. So it's basically a manifold that pumps out from the pump, up into the manifold, out into those 2 hoses, which are these hoses here that come up and go into the box, and they both have 1/4 inch. They both have 1/4 inch ball valves on them, right? So I can choose to run whichever one of these I want. Filter does its good job. It works good. With that being said, the reason why I went with this flex line is because I needed to be able to maneuver this around if need be, because I have plans to put another bucket there, maybe connect these 2 buckets together to give me 10 gallons, and that way I can also, if I get 10 gallons, this is a 20-gallon part, I can pump 10 gallons of liquid in here and soak parts if I wanted to in hot degreaser. And then once they're done soaking, I can simply turn a ball valve and drain them down back in. However, I would have to incorporate a ball valve here, and then if I do a second one, actually if I do one here, I would do a ball valve, and I'll just do a 2-way splitter to split into both buckets. I would not control the buckets individually. I would still have a bulkhead coming from the side and going into the other one, which would connect both of them together, and I will have 10 gallons. Okay, so I'm not gonna open this up, but inside here there is a PEX fitting underneath on the other end of this bulkhead that has a PEX line that goes all the way down about 1 inch away from the bottom of the bucket. That's cut at a 45-degree angle so it doesn't suck a lot of sediment off the bottom of the tank. Okay, and then here I have my thermocouple that's going in through a brass bulkhead, or no, I'm sorry, going in through a stainless bulkhead. Okay, and we'll talk about that in just a second. All right, So now, as I said, with these lines, these are a combination of NPT threads and compression threads. Now this is a fitting that you can get these at Home Depot or Lowe's on the compression section. This is a 3/8 NPT thread to a 3/8 compression thread. Okay, and you need the compression thread in order to use these because the 3/8 compression thread is not the same as a 3/8 NPT thread. NPT thread is far bigger than the 3/8 compression thread. Okay, so I laser cut a plate, and this was just an opening that was already in for the original pump. I laser cut a plate and I put the two bulkheads in here, two brass bulkheads connected a 90-degree 3/8 NPT to 3/8 NPT, male to female in. Then I went male 3/8 in, male 3/8 in, female 3/8, male 3/8 in, male 3/8 in, to male 3/8 compression, which was able to come down and do the connect to all the other compression fittings. The back of the bucket is a normal bucket. The reason why I went with this bucket, I was running that bucket at first, but that was a pain in the ass. And as you can see, I do have a ball valve on there, a union ball valve. And the reason why I stopped running that is because it was extremely difficult to take that out to change anything. Not to mention, it's plastic and it did start to bow a little bit when it started to get hot and when it was full. And I didn't like that. It was just the making of a disaster. So I decided to not go with that and go with the bucket, because also when that was full, that's 10 gallons. So when it's full, it's a little difficult to take that out of there, especially when you have that pipe and it's basically wedged up until the bottom of this. As you can see, you see the gray shower drain, which is the same piece as here, right? And so it was wedged in there. And like I said, water weighs 8 gallons a pound. So that was 80 pounds right there. It's a lot harder to carry or get out of there than if you're running in than 40 pounds. Okay. Not to mention, this doesn't go anywhere as high as that tank. That flex hose, all I gotta do is unscrew that right there, and then since it's flex, I can just pop it up, and now I can just slide the whole bucket out after I disconnect that line right there with a simple crescent wrench. Okay, so, and another reason why I went with all braided line is because it just makes it look cleaner. Okay, and I like clean builds. So the way that this works is the same method that is linked in the video below, how he did it. He decided to pull the liquid through the filter instead of pump it through into the filter, into the tank, because he wanted to save his pump. And it makes a lot of sense. You don't want to run sediment through your pump prior to getting filtered. This just makes 0 sense whatsoever. So the way it works is, here is where it pumps out, here is where it draws in. This line goes around and up and under, and it comes out right there and goes into the out port. So the suction from the pump is sucking this liquid through this way. Okay, so it's being filtered before it hits your pump. Okay, so, and it comes out, it sucks it through, it pulls it through all of this, and then as it comes into the tank or to the pump, as the pump pumps it out, it pumps it to that air manifold, or into that liquid manifold, which fills up and distributes it through those two lines that go up here. Okay, now what sets this apart from all the other ones I've seen so far is the fact that mine is controlled with the PID controller. Okay, for those that don't know what a PID controller is, it's basically a control. It basically regulates temperature. It gives power to a heating element and takes power away to keep it at a certain temperature. Now, I built this box, I don't know how long ago. I originally had built it for a powder coating oven, which I still can use it to control a powder coating oven because I have another plate and I have the ability to make different plates. I mean, I have a big laser engraver sitting right there, like, and so, I mean, I can make more, and I can simply put another, 2 of these side by side. And these things are also capable of running off of 220 volts, 240 volts. So, and clearly, a powder coating oven is usually 30, 40 amps at 200, 220 volts or something like that. So basically the way it works is I can turn this pump on. I can press this, it's plugged in. I did all the wiring on the inside. I'm not going to open this because I would have to unscrew all these screws around to open it, which that could be for another video. But all the wiring, I have the control box, the power box for the pump here, which is in one outlet. It's just a normal home outlet that has 2 plugs. And this one is for the heater. Now both of these run off of 110 volt. Okay, so there's really no weirdness going on here. And then that is the connection for my thermocouple, which goes into the bucket right down there. And if, for those that don't know what a thermocouple actually does or what it is, it's basically a temperature sensor. And it feeds, it tells, when I turn this on, when I get this powered, which I'm gonna do in a second, it will say how much the temperature is on the inside and and you set your target temperature. And the unit will supply power to the heater as needed to get the water or liquid as hot as you want it to your target temperature. And once that happens, that thermocouple that's in the bottom of the bucket, that temperature sensor, sends that back here and says, hey, we're at the target temperature. The unit then cuts power to the heater and in order to keep it from overheating the liquid. And then as the liquid cools down based off of its own ambient atmosphere or outer area, whatever you want to call it, then once it gets too cold or, drops maybe 1 to 2 degrees below your target, then it'll supply heat back or power back to your heater, which will get it back up to that target temperature again. And it basically keeps bracketing back and forth to keep you at a good temperature. So for my research, an optimal parts washer is between 120 to 140 degrees Fahrenheit. And I have mine set at 130 degrees Fahrenheit, so that's perfect for me. I don't want to get it really hot. This thing can get easily, that heater can get over 212 degrees. It can boil water, and we all know water boils at 212 degrees Fahrenheit, but I don't need it that hot, okay? So I can set it to what I want. This only sets temperature in Celsius, and if it doesn't, and someone is familiar with this exact kind of controller, which is the Inkbird 100 VH, I believe it is, then please tell me how to change it into Fahrenheit. So as of right now, it does that. When it hits the target temperature, this indicator light comes on, and I know it's done. So I can actually be standing at the top by the door up here and look down and see that the light's on and see that I'm in business. All right, so I got myself plugged all in right there. I'm gonna link all the parts to this parts washer below. I'm not selling the plans, because I don't want people to double pay for stuff. There's no sense of me in sense of me selling the plans if you're gonna just have to turn around and pay more money for parts. I don't like doing that. It's just not the kind of person I am. I don't do that. If I was in this for a business, then yes. The only thing I will charge somebody for is if they wanted me to build one of these for them. Then yes, I will have to. And if you want me to build one of those things for you, if you want to do this exact kind of setup or something similar and you need a box like that, then let me know. We can have a conversation about it. All right? Just hit me in the comments below. And don't forget to hit that subscribe button. Subscribe. So we'll go from there. And so now, without further ado, we're going to get into this. All right. Now I'm going to tell you there's a certain sequence that I shut this down and started up in. And the reason for that is because this pump is not a self-priming pump. So if you lose prime, then you're going to have to prime it again. But I accounted for that just in case. So I have a prime pump. I have the prime ball here. So if I do lose prime because I wasn't paying attention, or my son, which actually does work for me, he's 16 years old, he might forget and he might lose prime. So if it loses prime, then you can easily come up here. You can turn the pump on, open this valve, hit the prime. It pushes air this way, which is drawing air in through the whole system, hits the pump primes, and then we're back in business. But once it's primed, in order to keep it from losing prime, what I do is once it's doing its thing, I would let the pump keep going, close the valve, whichever one's open, close it. So the pump's still trying to go, so it stays primed. Then I turn it off. So that way there's still liquid throughout the whole system, also the pump. When you introduce air into that line and it's too much, it can kill the prime and then you'll have to reprime. Which, like I said, if you set it up correctly, it's not really a big deal. But, you know, why if you don't have to, right? So what I'm going to do, I'm going to turn it on. It should still be primed right now. So when I turn it on, then you can hear the pump going. It's not very loud at all. You can run this in the middle of the night. The indicator light comes on blue. You can see it, okay? And I can open this up. And you see the liquid is coming in through the brush, right? I'm running the Zep Purple degreaser in here, so you see the purple tinge. I could also, you know, shut this one off, open that one. There you go. That shoots degreaser. All right, so they're both closed. Let me open that one up. All right, so that's going. So now back to the box. Okay, so now the pump is on. I can clean things. You know, I don't necessarily need heat when I don't need it. So if it's just something that has like maybe some oil, brake fluid or whatever, I can just use non-heat. But if it's something like this thing that's grimy and I want to use some heat to get it as clean as I can, then I'll go on and I'll hit the heater, right? Which also supplies power to the PID controller. Now, this thing boots up. Now that it's booted up, as you can see it, you know what's so weird? How it does this on camera, but it's not doing it actually as I look at it. How it's doing that whole thing. I don't know if you guys can see that. That is always so fascinating to me. Somebody please tell me why it does that if you know, because I'm very interested in knowing. All right, so as you can see, this 54.4, that's my target temperature that I want it to be at, okay? Right now, it's being supplied. If you see this button that says out, that means that the unit is supplying power to the heater, right? To heat up the liquid, to get it up to this target temperature. So that's why you know it's the output, it's giving output power. Now, once this, like I said, this is all in Celsius. So 54, I believe that's about 130 degrees Fahrenheit, 54 degrees Celsius, somewhere around there. 35 is what I'm at right now, 35.4. Okay, so it's heating up, and this gets hot, right? It gets hot. So, and it pumps it through closed loop system and drains right back down into the tank. Any sediment is filtered right there. So my target temperature is 54.4. My current temperature that's being read is 36.7. Once it reaches 54.4, this is going to turn off this output light, because it's going to say, hey, we're at the target. We don't want to get it overheated and overheat the water or liquid, and so it's going to cut off. And then once the temperature senses that it has dropped at least a degree or two degrees below the target temperature, then it'll kick back on and start outputting power to get it heated back up again. So it'll give you a plus or minus 2 degree for heat. And that's what really sets us apart. You know, you got some metals. I might want to clean plastic, and I might only want a little bit of heat, a little bit of warmth. You know, I don't want to overheat plastic and melt plastic or whatever, or decolor, do whatever, right? So, and this is magnesium here. You know, I might not want to get things too hot, because certain degreasers or solvents could damage magnesium if they're too hot, or they're at the wrong temperature. So, you know, this is what makes it really good, the fact that I can control the temperature, and it takes about 10 minutes to get up to temperature. So, you know, you can go turn this thing on, go inside your house. Honestly, you could fall asleep, which I still don't recommend, but if you have this set, you can fall asleep and it's gonna stay at that temperature. You're not gonna wake up and it's gonna be at 200, 300 degrees, right? Steaming and shit. It's not gonna do that. So, and the ball here, you can see the ball has an arrow saying which way the airflow is, which is going down, going towards there. So it's basically drawing air throughout the system. So yeah, if I was to go inside and fall asleep, I can wake up 10 hours later and it'll be at between 54 and 56 degrees, plus or minus, right? Plus or minus 2. And I don't have to worry about it heating up and melting things of that nature and things like that. So yeah, I mean, that's it. That's what it is. And like I said, you know, I don't have any leaks in this system whatsoever. I'm actually looking into putting another container right next to it, like I said, and give myself 10 gallons so I can soak parts, hot soak them. But yeah, if you're interested in this, like here you can see I have a for pump and one for heater. And if you're interested in this, let me know. Leave it in the comments. Please don't forget to subscribe if you like this video. And I haven't seen any parts washers DIY at least. I don't know if there's any that are manufactured with a PID controller, but I haven't seen any yet. But if if you're interested in this, just if I get enough people interested, I'll just post a parts list below, and I'm gonna link that fine young gentleman video below that actually gave me the inspiration to do this. And I'll see you then.